In number 9, I'll start 9 over here. There's a little correction. That square root of 2 shouldn't be there. So just change that. No square root of 2. That is the equation I'm going to solve. Now, for me, I want to write the square term first, then the variable, and then the number. So I want to rearrange these things so it always looks the same, and I don't have to think too much. There's enough other problems I need to think about. This isn't one of them, so I rearrange them always the same. So I can apply my quadratic formula. Negative b is now negative 6 plus or minus square root of 6 squared minus 4 times 9 times 2. Close my square root over 2 times 9. Now I'll start calculating. For me, I like this in between step. What is inside the square root? I recommend you don't skip that step, but it's up to you. Totally up to you. I just make a mistake so easily with the calculator that I want to be set. What's inside the square root? Does anyone have a number for me? It says negative 36. Does anyone confirm the negative 36? No? I want at least 2 of you to get the number. So that we can be sort of sure. I don't think you can do calculations with a banana. That's impressive. That's impressive. He's just doing it in his head.
What's the square root of 6y?
No, I'm changing the question. It's a little typo. This is the question. Negative 36? The banana says negative 36. What does that mean? No solution. It's not always going to have a solution. There could be absolutely nothing you can plug in here that would give me a 0. It's essentially because this guy is too much. Too much. In combination, everything's added together. And you can't compensate to give me a 0. There's no solution. But that's another reason why I'm doing my in-between steps. There's a negative inside the square root, then stop. No, it's done. So I have different types of solutions to a quadratic equation. I can have 2 different solutions, but I could have no solution. So you have to spot when that happens. Okay. So again, we're not doing pre-calculus, so we're not really analyzing these things. In the pre-calculus class, I derive the quadratic formula and all those things. We don't want that. No need for that. I just want to be aware of some of these things that give me some basic skill. Z squared plus Z plus 1. Using the quadratic formula to practice. Well, there's no hope of factoring that anyway, so don't have a choice. Negative b plus or minus square root of 1 squared minus 4 times 1. Is it the one I want to use? Let me just check, sorry. This does not look like the one I want to be doing. Yeah, no, it's not. Sorry, there should be a 2 here. So this becomes a 2, and this becomes a 2. So just make that correction. 4 times 1 times 1. I'm changing the question, putting a 2 there. Okay? Over 2 times a, which is 1. My in-between steps, step calculates what's inside the square root. What is inside the square root?
0.
0. Does the banana refer to 0? Right. It's an organic calculator. So I get negative 2 plus or minus 0. So this whole thing falls away over 2. So I only have one solution, negative 1. Now I could have factored this guy as well, and I could have done it without the formula. Could have also said, oh well, this is z plus 1 times z plus 1. 1 plus 1 equals 2. And then I only get z plus 1 is equal to 0, or z plus 1 is equal to 0, it's the same thing. So in a sense, there is still 2 solutions, but they sort of fall on the same number, giving me what seems to be only one solution. So I can get 3 different things. I can get 2 different solutions, I can get no solution, or I can get exactly one solution. Any questions on this? Yeah.
Can you quickly tell me why that's no solution? I missed that.
What is the square root of negative 36? Is there any number that I can multiply by itself to give me a negative number? Nothing.
So every negative number there's no solution.
Banana says no. You can't evaluate the square root of a negative number. Because even negative 4 times negative 4, it's always going to be a positive number. Any number times itself is always going to be positive. Now, if you're really interested, we do get it. You can do this, but it's not with real numbers. So in the setting of our numbers with the real numbers, we say there's no solution. There's no number that represents the square root of negative 36. Okay. So this is just some sort of background that I feel we should see, trying to keep it to a minimum. Our main goal is to do something slightly more practical, sometimes a business type problem, sometimes not. But in any case, something more practical, something more using word problems, things that are more realistic. Now, in my experience, no one likes word problems, but when you step out of the classroom, everything's a word problem. Your boss is never going to say, oh, solve this equation for me. It's so nice. They're going to give you some wordy question, some wordy problem, and you have to figure out how to solve that. It's a word problem. Let's do 11 and 12 at least as a start for today, and on Friday we'll just do word problems. 11. The area of a rectangular picture with a width 2 inches less than its length is 48 square inches. What are the dimensions of the picture? So now I go back to my steps from 2 days ago where I have to define a variable. What do you want as the variable? This is a democracy. You tell me what you want. M. What does M represent? More than one choice here. What do you want M to represent?
Be the length. So it's
The length?
48 inches. Square.
Length of the picture. Let's have a sketch here. So this is M, and this is M. Do I need another variable?
No.
If there's any way I can get away with not defining another variable, I'm going to take it. Because the fewer variables I have, the better, the easier things are. But I do need to talk about the width. How can I represent the width if I don't want to define a new variable?
Something minus m.
He says m minus 2. Let's say here is represented by m minus 2. Put in brackets one thing. Because they say the width is 2 inches less than the length. So now my equation should represent the other information that the question is giving me, and that information refers to the area of the picture. Say again?
So dimensions is the same thing as
No, dimension is length and width. Area is length times width. But the information they give me is that the area equals 48 square inches. How do I calculate the area of this? Well, this is n minus 2, and this is n minus 2. So the area using my variable is m times m minus 2. So whatever m is, it has to give me an area of 48. So now swap everything, m squared minus 2m minus 48 equals 0. Is everyone happy where I get that equation? There's a times here, yes. Negative times. That's why I make a sketch. This is the length, this is the width, just multiply. Okay? So now I have a quadratic formula, quadratic equation. I can decide to solve this. I can either try and factor this. If I can't factor this easily, then I do have the quadratic formula to fall back on. Let's at least give it a shot. Because if I can't factor it, it's going to be much faster than using the quadratic formula. So, and I think I might have a shot because there's no fancy number in front of the square. So I may have a chance. So I try, see what happens. If I can't do it in a reasonable amount of time, then I move on. So now I'm looking for factors of 48. So that when I a factor pair of 48, when I subtract them, I need to get a 2. 8 and 6. This negative tells me the signs have to be different. This guy says the bigger one gets a negative. And even if I'm not sure, is that right? Foil it out. If I get this, then yes, I got it. I do get the negative 48. It's negative 8m plus 6m. That's negative 2m, so it's right. So that saves me a whole bunch of work. So m minus 8 is 0, or m plus 6 is 0. M is equal to 8, or m is equal to negative 6. No? Negative 6. No. This one's not applicable. Remember, it's so tempting to think at some stage when you do math, you think these things are just magical and they know what they're doing. This equation has no idea what I'm trying to do. I set it up to try and answer my question. It doesn't know I'm thinking about a picture with positive length and width and things like that. It's just an equation. I'm just solving that equation. And if I just look at the equation without any practical meaning behind it, there are two solutions. I have to go back and think, do both of those solutions make sense? No, negative number doesn't make sense. So I ignore this one. And my solution for the equation is 8. A little sentence to say what the dimensions of a picture are. The picture is 8 by 6. I guess inch length. We're using a variable equation to answer the question. The equation doesn't know what I'm trying to do. So I have to check the solutions I'm getting from the equation. What do they mean for me, knowing what the actual question is?
Sorry, I switched.
Fair enough. One more. What time is it?
2:01.
Okay. I can't tell. My watch is moody. I think it's something I said. All right. This one's a little physicsy, but it's okay. We will get more business type examples eventually. Suppose the height h of an object thrown straight upward from the ground is given by h equals 39.2 times t minus 4.9 times t squared. Where h is in meters and t is the elapsed time. After I throw it, I start the clock, and time increases the value of t. After how many seconds does the object strike the ground? Now, how do I interpret what they're asking and what I need to do with this equation? Isolate t. Sure, you're not wrong. But can I use, they're giving me extra information. They want to know what happens when the object strikes the ground. What happens? Yes.
Well, if it strikes the ground, h is 0. The ground is 0.
The ground is 0. So when it strikes the ground, h equals 0. So I can simplify my equation to 39.2 t minus 4.9 t squared equals 0. What is the time now? That is now the specific case where I'm on the ground. What is the value of t? Well, this isn't the most general quadratic equation because I don't have the third term, so I can factor out t. I don't need to run to the quadratic formula. Give it a shot first. Oops, there's no t there. Minus 4.9 t equals 0. It's sort of a balance. If I can avoid the quadratic equation, I probably can do it faster. But if I don't know, the quadratic equation will always work. So t is equal to 0, or 39.2 minus 4.9t is equal to 0. What is this solution here? 39.2 over 4.9. What's that? Oh, the banana's down. Now we have no hope to get it. 8? Wow. That's a nice, convenient number. Do both of those solutions make sense? Remember, this equation doesn't know what I'm trying to do. Does it make sense for what I want? The solution to me, yes.
So like in this case, you wouldn't use the quadratic formula because
You totally can,
you know your third number.
but it's going to be more work than that.
So there are the reasons why you wouldn't use it?
Sorry?
Like what are the reasons why you wouldn't use
But
it?
I can't factor. Then I use the quadratic formula. Here I can factor out a t. So I don't need. There's nothing wrong with it. You can go and test. The quadratic formula is going to give me the same answer. But it's a little more work if I can just factor. Factoring is faster, but if I can't see it, I do have that fallback. That is always going to do. The quadratic formula is always going to give me the answer. So I have an option. You can totally decide. I'm going with the fastest one. Do both of these values of t make sense? Why is there a 0? Why is t equal to 0 when h is equal to 0? What does that represent in the throwing of the ball? Object. When I launch the ball, I start the time and I'm on the ground. That's not what I'm looking for. I'm looking for when it strikes the ground again. So this one is not relevant to me. And this one is. So it strikes the ground after 8 seconds. So I do have to be able to interpret the solutions to the equation and see which one makes sense to me, which one is actually the answer to my question. The equation doesn't know what I'm trying to do. B, and we're done. When is the object at a height of 68.2 meters? So what's actually happening here, if I sketch this, which we will eventually, but not right now, if I let time change and see how the height changes, the object is going to travel like that. It's going to start at height at the ground level and eventually get back to the ground level as time passes to 8 seconds from 0 to 8. It's going to reach a maximum height and then turn back around. When is it going to reach a height of 68.2? There might be 2 time values. What are these time values? If it's going up, it passes that height. And maybe it goes higher and comes back down and it passes the 68.2 mark again. So I expect to possibly get 2 answers that make sense. Let's see what we get. Now I have to go to my equation that I just erased. And I'm now looking for an h value of 68.2 in my equation. There's my equation. Now I have no open factor. That is, there's no chance. So I move everything to the left to get 4.9t squared minus 39.2t plus 68.2 equals 0. And I'll let the quadratic formula do the work for me. I can't factor it right away. Then I have the safety of the formula. And I'll have to plug it in and be careful in my calculations. Negative b, so that's negative 39.2 plus or minus square root of negative 39.2 squared minus 4 times 4.9 times 68.2. Close my square root. A little messy, but not that bad. Over 2 times 4.9. All right. I just make mistakes if I try to do this in one go on the calculator / banana. So I'm just going to calculate the inside of the square root first. And by I mean u. What's inside the square root? Hold on. 199.92. Is anyone confirm her number? Okay. Now it's a much simpler calculation for the calculator. I get 2 different values. What's the one if I use a plus? What value do I get? 2 different values. One uses a plus, one uses a minus. Let's do the plus first. What number do I get here? Everyone's just sitting back and letting one of 4 or 5 people do it.
If you minus it, I got 2.55.
And the plus?
I didn't do the plus. Okay.
Fair enough. She did one of them. I'm sure someone else can do the other one. But the benefit of trying to do it here is if you can get it, then you know, okay, I'm probably okay. I'll practice a little more, I'm good. If you sit back and letting someone else do it, that's a risk you take. What is the other times value that I get?
5.44.
Sorry, say again?
5.44.
5.44. So as I expected, it passes the height line, 68.2, when it goes up and when it goes down. So, what's the question? So it's at a height of 68.2 meters at times 2.55 seconds, and when it comes down, that's at 5.44 seconds. So as soon as we go to a more practical situation, the numbers aren't as nice anymore, and that's where the quadratic formula really benefits. Any questions on this? So have a look at the homework, see how you feel about these things, and then we'll do more practice questions on Friday.